We're going to go over some of these examples from section 10.1. Determine the null and alternative hypotheses. State whether the test is two-tailed, left-tailed, or right-tailed. According to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. So first of all, notice that they're referencing the mean. That is the parameter that the hypothesis will be about. And then it has the word increased. Okay, so the null hypothesis, H naught, is always a statement of no change. It always has an equal sign. And it's usually some predetermined amount or previously accepted amount. So this H naught will say mu equals 3.25. And that was the previous understood mean of a phone call. The alternative will challenge that, and we have the word increased. So the alternative hypothesis, H1, will say that mu is now greater than 3.25. So when you write your hypotheses, the same number should appear in both hypotheses. All right, part B. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has changed. So this time the parameter in our hypothesis will be standard deviation. We don't see a word like increase or decrease or has gone up or down, but we do see the word change. And when you see the word change, that refers to not equal to inequality. So here the null hypothesis is that the standard deviation, sigma. Now keep in mind that your hypotheses will always be about parameters because hypotheses are statements about populations. That sigma is this old value they knew used to be the standard deviation, 0.23. The manager thinks that the standard deviation has changed, didn't give an opinion about which way it has changed, so our alternative will be not equal to. Sigma is not equal to 0.23. Now, anytime you see a not equal to alternative hypothesis, this is called a two-tailed test. That's because your sample evidence could be either larger or smaller than 0.23. It's not specific. This one above with the greater than symbol, that's called a right-tailed test. This means your sample evidence should occur on the right tail of your distribution. Okay, let's look at some more examples. In 2007, the mean SAT score on the reasoning test for all students taking the exam was 486. A teacher believes that due to changes to high school curricula, the mean has decreased. Okay, so once again, they're referring to the mean. So mu will appear in our hypotheses. The null hypothesis will be that the mean is still this old value that it was known to be, 486. The teacher believes the mean has decreased. That means our alternative will say that mu is now less than 486. Okay, so part B says, explain what it would mean to make a type 1 error. A type 1 error occurs when you reject H naught, but H naught is actually true. So let's write that down and then write out kind of what it would mean in this context. Reject H naught, but H naught is true. Keep in mind with these errors that they have names, they have classifications, and they have certain probabilities associated with them. But you will never know if you've made an error or not because you don't know the true value of the parameter. That's why we have hypotheses. If you knew the value of the parameter, there'd be no point to doing a hypothesis test. Okay, so type 1 error means the teacher concludes, so she's rejecting H naught in favor of H1. The teacher concludes the mean has decreased, but it actually has not. Oops, spelled it wrong. The teacher concludes the mean has decreased, but it actually hasn't. Okay, and she wouldn't know if this error occurred, but that's what that means. Part C, explain what it would mean to make a type 2 error. So type 2 error means you do not reject H naught, but H1 is true. So if H1 were actually true, you would want to reject H naught. So in this case, the teacher would conclude that the mean has not decreased, but it actually has. The teacher concludes that the mean score has not decreased, but it actually has. Okay, let's look at some other examples. So we're going to now, revisiting that same problem, write out some conclusions. So we want to state the conclusion when the null hypothesis is not rejected. When the null hypothesis is not rejected, that means that your sample evidence was not strong enough. So we would say there is not sufficient evidence. There is not sufficient evidence to conclude that the mean SAT score has decreased. That the mean SAT score has decreased. So in your conclusion, you kind of restate the alternative hypothesis. I use the word decreased. You could choose to say there is not sufficient evidence to conclude that the mean SAT score is less than 486. That would also be okay. There isn't always necessarily only one correct way to write this. Just make sure that in your conclusion you are restating the alternative hypothesis in some form. Using the context of the problem, you want to say mean SAT score. You don't want to just say mu. You want to be a little bit more specific. Okay, so let's say that the sample evidence actually was strong and the null hypothesis was rejected. We would say there is sufficient evidence. There is sufficient evidence to conclude there is sufficient evidence to conclude that the mean SAT score has decreased. So I'm once again reiterating the alternative hypothesis. Looks like I forgot the word evidence up here. Let me add that in. Okay, so these are the only two conclusions you'll ever make. You will either say, you will either reject H naught or you will not reject it. We never accept H naught. You either say your evidence is strong enough to reject it or you do not have strong enough evidence to reject it. That seems very careful. It is. It's kind of similar to a court case. The two verdicts that a jury chooses from are guilty or not guilty. Those are the only two choices. They never rule someone innocent. So they either think the evidence is compelling enough to say someone's guilty, or they don't think there's enough evidence to say that. So it's a very similar idea. We will either reject H naught or we will not reject it. And then the conclusions will always take on this structure that we wrote here. And just make sure that you restate the alternative hypothesis in your